My dear students, previous 3 classes we have discussed a lot of things about the electric capacitance. In the class 3 we have discussed about the dielectric. So in fact, what is a dielectric? Dielectric means it is an insulator that induces electric field but not electricity. That's why, so dielectric are again categorized as polar dielectric and non-polar dielectric. Clear? And after that we have discussed a lot of things. So dielectric induce electric field due to its polarization. Now we will discuss about a lot of things about the grouping of dielectric as well as some numericals on capacitance and grouping of dielectric. And later we will discuss something about the numericals on effective capacitance of different electric circuit. Clear? Let 3 capacitor of capacitance 2 microfarad, 3 microfarad and 4 microfarad are connected in parallel. If charge through 2 microfarad capacitor is 10 microcoulomb, find the total potential difference and charges across each capacitor. Listen to me. 3 capacitor of capacitance 2 microfarad, 3 microfarad and 4 microfarad are connected in parallel. So let this is one capacitor, this is another capacitor, this is another capacitor. Clear? Let it is 2 microfarad C1, let it will be 3 microfarad and C3 will be the 4 microfarad. Capacitors are said to be in parallel if the positive plate of each connected to one terminal of the power supply, that is positive terminal of the power supply, and negative plate of each connected to negative terminal of the power supply. In parallel combination, what remains constant? In parallel, potential difference V remains constant, while charges are variable. Okay, let it will be Q1, let it will be Q2, let it will be Q3 and the potential difference will be V. As 3 capacitors are connected in parallel, 3 capacitors connected in parallel, the V is constant. Well, the charge, but it is, Chandra, if charge through 2 microfarad capacitor is 10 microcoulomb, it means charge Q1 is given as a 10 microcoulomb. Clear? As we know, C is equal to Q by V, or I can write it V is equal to Q by C. Clear? So C is equal to Q by V means V is equal to Q by C, or I need this V, V is equal to Q1 Q by C1 because Q is constant. Sorry, Q is variable. Well, V, so we need what? So Q is given as 10 microcoulomb. Sorry, Q is 10 microcoulomb and C1 is 2 microfarad. If it is so 10 into 10 to the power minus 6, 2 microfarad, capacity is 2 microfarad, means 2 into 10 to the power minus 6, 10 to the power minus 6, 10 to the power minus 6 cancel each other. Now it is found to be 5 volt that is V. So V is constant. So this 5 volt is constant across each capacitor. It means this C1 is also having 5 volt, C2 is also having 5 volt, and C3 is also having 5 volt because they are in parallel. Now Q2 is equal to how much? C2 into V, because V is constant. So C2 is how much? 3 microfarad means 10 to the power minus 6. V is found to be 5. Therefore 15 into 10 to the power minus 6 is equal to 15 microcoulomb. This is Q2. Similarly, Q3, C3V is found to be, C3 is how much? 4 microfarad. 4 into 10 to the power minus 6 into V is again 5 volt because V is constant. That is 20 into 10 to the power minus 6, or I can write 20 microcoulomb. Therefore, total charge Q is equal to Q1 plus Q2 plus Q3. Clear? So this is net charge. Q is found to be how much? Q1 is 10 microcoulomb given. 10 plus 15 plus 20, that is 45 microcoulomb. Clear? So it is asking that potential difference, find the total potential difference and charges. It means potential difference is constant. So 5 volt is across each capacitor, while charge is different in different. The first capacitor is 10 microcoulomb charge, which is already given in the question, while 15 microcoulomb is across second capacitor and 20 microcoulomb across the third capacitor, while the total charge is found to be 45 microcoulomb. Clear? Next. If 3 capacitor of capacitance 8 microfarad, 12 microfarad and 16 microfarad are connected in series, and potential difference across 12 microfarad capacitor is found to be 60 volt, then find charges and potential difference across each capacitor. Now the question is series connection. It means 3 capacitors are connected in series. So capacitors are said to be in series if the positive plate of a second capacitor connected to the negative plate of first, and negative plate of the second connected to the positive plate of next, and so on. Then the capacitors are said to be in series grouping. In series combination, the charge flow across each capacitor are constant, while the potential difference is different. Let this is C1 capacitor, C2 and C3. Positive plate, negative. Positive plate, negative. Positive plate, and this is negative. C1 is given as 8 microfarad, C2 is given as 12 microfarad, and C3 is given as 16 microfarad. Clear? Let the potential drop across V1. C1 is V1, C2 is V2, and C3 is V3, and net potential drop is V volt. Clear? So in series, charge Q is equal to constant, while potential difference V is variable. So it is given 3 capacitors are connected in series and potential difference across 12 microfarad is 60 volt. It means V2 is given as 60 volt. Clear? So charge Q is constant. Clear? So according to the formula, C2 is equal to Q by V2, or I can write it Q is equal to C2 V2. C2 is given as 12 microfarad, 12 into 10 to the power minus 6, and V2 is given as 60. So it is found to be 720 into 10 to the power minus 6, or I can write it as a 720 microcoulomb. Clear? This Q is constant throughout the capacitor. It means the charge through each capacitor are equal. So this is constant. Now we need V1. Therefore, V1 is equal to Q by C1. Q is found to be 720 microcoulomb and C1 is found to be 8 microfarad. That is 8 into 10 to the power minus 6. How much? 90. Clear? Now we need V3. So V3 is equal to again Q by C3. So Q is found to be 720 microcoulomb, 16. 8 to the 16. So it is found to be 10 to the power minus 6, 10 to the power minus 6, 45 volt. Therefore, B2 is given 60 volt, B1 is found to be 90 volt, and B3 is found to be 45 volt. Therefore, net potential V is equal to B1, B2 plus B3, because in series the net potential is equal to algebraic sum of individual potential according to the principle of superposition. So V1 is how much? V1 is 90, B2 is given 60, 45. It is found to be 195 volt. That is, the net potential drop across the circuit when connected in series is found to be 195 volt, while the voltage across first capacitor is 90, voltage drop across the second capacitor is 60, and voltage drop across the third capacitor is 45 volt. I would like to say that when the capacitors are connected in series, charge remains constant while potential is variable. But when connected in parallel, charge is variable and potential is constant in parallel. Clear? Next. When two capacitors, when connected in parallel, let it tell C1 and C2. So Cp is equal to C1 plus C2 is equal to 10 microfarad. When such capacitors are connected in series, the effective capacitance is C1 C2 by C1 plus C2 is given as 1.6 microfarad. Clear? When two capacitors are connected in parallel, the effective capacitance is 10 microfarad, and when such capacitors are connected in series, the effective capacitance is 1.6 microfarad. Then find C1 is how much and C2 is how much. So in series we know that C1 C2 by C1 plus C2 is equals to C1 C2 by C1 plus C2. We know The value is 10 microfarad is found to be 1.6. So C1, C2 is found to be 1.6 into 10. That is 16. Clear? Therefore, C1 minus C2 the whole square is equal to C1 plus C2 the whole square minus 4C1 C2. So C1 plus C2 is how much? 10. 10 to the square minus 4 into C1 C2 is 16. So 100 minus 16 for the 64 found to be 36. Therefore, C1 minus C2 is equal to 36 root is 6 and C1 plus C2 is 10. Therefore, by cancelling C2 we find 2C1 is equal to 16 and C1 is found to be 16 by 2, that is 8 microfarad. Clear? Now, when these capacitors are connected, C1 plus C2 connected in parallel, C1 plus C2 is 10, but we know that C1 is 8. Therefore, C1 plus C2, instead of C1 I can write 8 plus C2 is 2, found to be 10. So C2 is equal to 10 minus 8 is equal to 2 microfarad. Clear? It means when 8 microfarad capacitor and 2 microfarad capacitor are connected in parallel, that is C1 plus C2, that is 8 plus 2 is found to be 10. Correct? So when they are connected in series, that is C1 C2 by C1 plus C2, that is 8 into 2, 16 by 8 plus 2, 16 by 10 is 1.6. Hence this is our right answer. Clear? Next. N number of identical capacitor are connected in parallel and then removed. Again, connected in series. Find the ratio of the effective capacitance. Clear? N number of identical capacitors are first connected in parallel and then removed, again connected in series. Find the ratio of their effective capacitance. It means if the capacitor is first connected in parallel, how much? Then connected in series is how much? Then find their ratio. As we know that in parallel combination, effective capacitance Cp is equal to how much? C1 plus C2 dot Cn, because it is mentioned that they are identical capacitor. It means all the capacitors are having same capacitance. If they are having same capacitance, then C1 is equal to C2 is equal to C3 dot Cn or C. Therefore, capacitance in parallel found to be C plus C. See how many times? N times. Clear? Therefore, Cp is found to be Nc. This is equation number 1 when connected in parallel. Now, in series, 1 by C effective, that is 1 by C series. Let instead of effective capacitance I put it C series is found to be 1 by C1 dot 1 by Cn. But all the capacitors are identical, having the capacitance C. Then 1 by Cs is found to be 1 by C n times, and CS is found to be C by n. This is equation number 2. Find the ratio of their effective capacitance when parallel. Their effective capacitance is NC, and when series, their effective capacitance is C by N. Therefore, the ratio of the CP by CS found to be NC by C by N. So they cancel each other and found to be N square. That is the ratio. That is the square of the number of capacitor. Clear? Two capacitor of capacitance 20 microfarad 50 volt and 10 microfarad 20 volt are connected in parallel. Find the common potential and also the loss in energy in sharing of capacitor. Listen to me. Two capacitor of capacitance 20 microfarad 50 volt and 10 microfarad 20 volt. When two different capacitor having different potential, when connected in parallel, there is a charge flow from higher potential to lower potential until and unless the potential of each capacitor are equal. Until and unless, and such potential is called common potential. Clear? This is a capacitor and it is another capacitor C1, C2 having potential V1 and V2. Clear? So when two different potential as V1, so there is a charge flow from high potential to lower potential until and unless the potential of each capacitor are equal, and that potential is called common potential. So formula V is equal to total charge Q1 plus Q2 by C1 plus C2, Q by C. So V is found to be Q1 is equal to C1 V1, C2 V2 by C1 plus C2. So C1 is given as how much? 20 microfarad. So 20 into 10 to the power minus 6. V1 is given as 50 volt plus C2 is given as 10 microfarad, 10 into 10 to the power minus 6. V2 is given as 20 volt. So C1 plus C2, that is 20 microfarad and 10 microfarad. 20 plus 10. So microfarad taken common. Clear? Listen to me. 10 to the power minus 6, 10 to the power minus 6 if I take it common. 20 into 50, that is 1000. 20 into 10, that is 200 into 10 to the power minus 6 whole by 30 into 10 to the power minus 6. So minus 6 cancel each other. It is found to be 1200 by 30, that is 0 cancel, 120, that is 40 volt, that is the common potential. When the two capacitor acquire the 40 volt, then there is no more sharing of charge. Clear? Now, Whenever there is a sharing of charge, when there is a sharing of charge flows from one capacitor to another, it means there is some loss in energy. That loss in energy is equal to energy before sharing minus energy after sharing. Clear? Before sharing is half C1 V1 square, half C2 V2 square. This is the energy before sharing, and after sharing they acquires common potential, that is V, half C1 plus C2 into V square. As we know that loss in energy is found to be half C1 C2 by C1 plus C2 into V1 minus V2 whole square. Clear? So half C1 is given as 20 into 10 to the power minus 6. C2 is given 10 microfarads. 10 into 10 to the power minus 6 whole by 20 plus 10. So V1 minus V2, V1 is 50, V2 is 20, 50 minus 20 whole square. Clear? So 10 to the power minus 6, 10 to the power minus 6 cancel out. 30, 2, 10, 100. 100 by 30 is found to be this is 10, 100. 100 by 30 into 50 minus 20, that is 30. 30 square is 900. Clear? And 10 to the power minus 6. Clear? 0, 0, 3, 30. So there will be 3 0 eliminated. It is found to be 3 into 10 to the power minus 3 joule. This is the amount of energy lost when two different capacitors of different potential having 50 volt and 25 volt are connected in parallel. Clear? This is the important questions which comes regularly as a CHSE as well as in CBSE. Sharing of capacitor is the most important 3 mark questions. Clear? Grouping of dielectric. When a capacitor, parallel plate capacitor is inserted with a dielectric slab, there is a change in its capacity. Let n number of capacitor, dielectric, let it will be K1, K2, dot dot dot. K. T1, T2, T3, Tn. I would like to say that when different dielectric having same area but different thickness, when are put into a capacitor, then such dielectric are said to be in series grouping. Listen carefully. When dielectric having same area, there is no change in area but different in thickness are placed in between the parallel plate capacitor, then they are said to be in series. That is series grouping. Clear? As we know that capacitance in medium is found to be A epsilon 0 D into K effective if there is only one dielectric. Let it will be having different dielectrics of thickness T1 T2. Then the capacitance will be, C medium will be found to be A epsilon 0 D minus T1 T2 up to Tn. That is the thickness of all the slabs, plus T1 by K1, T2 by K2 and so on, Tn by K. Clear? If the slab is completely replaced, if the dielectric slab completely replaced by the air between the two parallel plates, then D minus T1 plus T2 dot 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 Tn tends to 0. Okay? If thickness of all slab are equal, it means how many? N dielectric slab are placed in series. So total thickness is how much? D. It is divided into N segment. So each one becomes D by N. Clear? So the thickness becomes how much? D by N. So this factor becomes how much? Tends to 0 as the slab is completely replaced by A. Now this formula becomes C medium becomes A epsilon 0 by D by N. Come on, because T1, T2, Tn are equal, having same thickness, is found to be 1 by K1 dot 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 1 by Kn. Let it will be equation 2. Clear? Comparing equation 1 and 2, you can write the equation in such a way also. A epsilon 0 by D by K effective. Clear? If you write it so, A epsilon 0 by D is taken common. By comparing 1 and 2, here listen, A epsilon 0 by D, A epsilon 0 by D is given 1 by K effective. 1 by K effective is equals to 1 by N. 1 by K1, 1 by K. So this is the formula when the number of dielectric are in series. Again I am expressing that when the dielectric are placed into the parallel plate capacitor having equal area but different thickness, then they are said to be in series. It means when the area remains constant but thickness varies, then they are said to be in series. Clear? So in series combination is this. Let us imagine if the total capacitor is replaced by only two dielectric. Let it will be K1 and it will be K2. So here the number of dielectric tends to 2. So if two dielectrics are there, N tends to 2. So formula becomes 1 by K effective is equal to 1 by 2, 1 by K1 plus 1 by K2. Clear? Did you get me? So it is can be written as K1 plus K2 by 2K1 K2 is equal to 1 by K effective, or I can write it as a I can write it as a K effective is equal to 2 K1 K2 by K1 plus K2. Clear? Some questions are asking us, let a parallel plate capacitor having dielectric of K of equal area, but the half of the width of the two parallel plates and the remaining half is covered with air. Find the effective capacitance. Clear? So listen to me. Here K1 is K given, while K2 is for air. Dielectric constant is 1. Clear? Therefore, the effective capacitance is how much? 2 K1 K2 by K1 plus K2. So instead of K1 I can write K. So it is found to be 2K into 1 by K plus 1. Clear? So therefore capacitance is found to be A epsilon 0 by D into K effective, and A epsilon 0 by D instead of K effective I can write 2K by K plus 1. Clear? Let us discuss about the dielectric in parallel. Let listen to me. When dielectric are said to be parallel, previously I have discussed that when the dielectric are having equal area but different thickness are said to be series. Now I would like to say that when the dielectric are having different area but same thickness is called dielectric in parallel. So here thickness is constant but area is different. Clear? So in this case effective capacitance is, let C medium is found to be A epsilon 0 by D into K effective, let it will be equation number 1. That is, if two dielectric are replaced by same or single dielectric, the answer is C medium is equal to A epsilon 0 by D into K effective. Clear? Now, so in this case, these two capacitors are there. I can think it is a combination of two capacitors connected in parallel. Okay, so let it will be C1 and C2. So net capacitance is how much? C1 plus C2. Therefore, C medium found to be how much? C1 plus C2. C1 is equal to A by 2 epsilon 0 by D into K1. C2 is how much? Again area A by 2 epsilon 0 by D into K2. I can take common A epsilon 0 by D, so found to be K1 plus K2 by 2. This is equation number 2. Comparing equation 1 and 2, if two dielectric are replaced by single, then the answer is this. Now the answer is found to be this. So effective capacitance when dielectric are in parallel, then the effective dielectric is found to be K1 plus K2 by 2. So as the area is divided into two halves, so it is K1 plus K2 by 2. If someone will going to ask that, sir, if the dielectric are having each area is divided into n segments, then each area becomes A by n, or for n dielectric slab, K effective is found to be K1 dot 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 Kn by n. Clear? This is the effective capacitance when dielectric are in parallel. Clear? Now, listen to me. This is a medium having K and another is having A. Find the effective capacitance. If half of its area is covered with a dielectric K and the next half is A, find the effective capacitance. In this case, K1 is how much? K. K2 is K how much? 1. Therefore, K effective is found to be K1 plus K2 by 2 or K plus 1 by 2. That is K effective. Therefore, capacitance is how much? A epsilon 0 by D into K effective. Clear? So, A epsilon 0 by D instead of K effective, I can write K plus 1 by 2. This is the effective capacitance of a such capacitor. Did you get me? How the capacitors are treated as a series and how it is treated as parallel. Next. Now we will discuss different types of capacitive circuit. When it is treated to be series and when it is treated to be parallel. We will discuss one by one. Let one. C1, C2, C3. Each one is C. Find the effective capacitance across X, Y. Find the effective capacitance of this combination. Listen to me. If this is the positive plate, this is negative, this is positive, this is negative, positive and negative. Listen, the negative plate of the first capacitor connected to the positive plate of the second, and the negative plate of the second connected to the positive plate of the next. So, such combination are said to be series combination. So, in series, 1 by C effective is equal to 1 by C1, 1 by C2, 1 by C3. But here 3 capacitors are identical, equal. So I can put it as a 1 by C, 1 by C, 1 by C, or 1 by C effective is found to be 3 by C, or I can write effective capacitance is nothing but C by 3. Clear? Let three capacitors C are connected in such a way, then find the effective capacitance across XY. Listen to me. Here this is positive, 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 negative, negative, negative. It means the positive plate of each capacitor. Positive plate of each capacitor connected to the one end, while negative plate is connected to the next end of the power supply. If this is the condition, then it is called parallel combination. In parallel combination, the effective capacitance is how much? C1, C2, C3. But here 3 capacitors are identical, so I can write C plus C plus C. It is nothing but the answer is 3C. Clear? C. 3 capacitors are connected as shown as in the figure. Find the effective capacitance. So xy, across the xy. So I would like to say that three capacitors. Let this is x, this is a conducting wire. So in case of conducting wire, there is no potential drop. So if this is x, then this is also x. If this is y, this is also y. So I would like to say that in xy there is a capacitor, in xy there is another capacitor, in xy there is again capacitor. So such combination is analogous to such combination. So effective capacitance is found to be C1 plus C2 plus C3 and again 3C. Clear? Next. Listen to me. C. Find the effective capacitance across xy. In this circuit, this is the positive plate, this is positive, negative, negative, and this is positive. I would like to say that these positive plates are connected to one another. So such combination is also a parallel combination. So at first we have to find out the effective capacitance of these two capacitors. Effective capacitance of these two capacitors. So it is found to be, so how much? C parallel is how much? C1 plus C2. It is C plus C. It is found to be 2C. So the circuit becomes how much? This is a 1. So this is 2C and this is C. Listen, positive, negative, positive, negative. If the negative plate of one connected to the positive plate of the next, the negative plate connected to the positive plate of next. So they are again series combination. So answer is 1 by C effective is equal to 1 by C1, 1 by C2 and found to be 1 by C effective is equal to 1 by 2C plus 1 by C is equal to 3C by 2C square, or I can say 3 by 2C, or conclusion C effective is equal to 2 by 3C. Clear? If in this circuit, how many capacitors are? 3 capacitors are there each. Listen to me. If this is positive plate terminal and Y is negative terminal, then this is positive and this is positive. Clear? This plate is negative. So negative plate of this connected to positive plate of next. So these two are series grouping. So in series grouping, if you find the effective capacitance of these two, found to be C series is equal to C1 C2 by C1 plus C2. So each is C. So C into C by C plus C, found to be C square by 2C. It is nothing but C by 2. Clear? So this circuit is analogous to this is C by 2 and this is C. Clear? Therefore this is again how much? Parallel combination. Positive plate is connected to positive. So these two are parallel. So in parallel, the effective capacitance is C1 plus C2, and C1 is how much? C by 2. C by 2 plus C is found to be 3C by 2. That is answer. Clear? This end is X and this end is Y. So this is positive, negative, positive, positive, negative, Listen to me. First we have to reduce the size of the circuit. This is positive, this is positive. So first we have to solve these two. These two capacitors are connected in parallel. So effective capacitance is, for these two, C effective is how much? C1 plus C2, that is C plus C, found to be 2C. Hence the circuit reduces to how much? This is C, 2C, this is C, C. So these three are now in series combination. Clear? So these are in series combination. So effective capacitance C effective is equal to 1 by C1, 1 by C2, 1 by C3. That is 1 by C, 1 by 2C, 1 by C. By taking LCM, 2C. 2 plus 1 plus 2 is equal to 5 by 2C, or C effective is found to be 2 by 5C. Clear? Some important part I would like to say that is called Wheatstone bridge. For Wheatstone bridge, this is called Wheatstone bridge. Let it is C1 and C2, C3 and C4, C5. If the circuit is balanced, I would like to say that if the potential at this point and potential at this point are equal, then there is no charge flows through the circuit. That is called balanced condition, or at balanced condition, let it will be A and B. VAB is equal to 0. There is no potential drop. Therefore, no charge flow through C5. So this is invalid. Hence, the circuit reduces to this is X and this is Y. C1, C2, C3, C4. So these two become series. These two become series, and this becomes parallel. Therefore, the effective capacitance becomes, this is series, formula is C1, C2 by C1 plus C2. For these two series combination. For these two, C3, C4 by C3 plus C4. But these two combinations are in parallel. So, effective capacitance is that much. Clear? Now the question is, sir, if the potential of if the capacitance 4 are equal, C1 is equal to C2 is equal to C3 is equal to C4 and C, if all the capacitors are equal, then C effective, C to C, C square by C plus C, 2C, so C square by 2C is found to be C by 2. Again, this is also C by 2, hence the effective capacitance is found to be C. I hope an important question is in the CBSE this year. This is the circuit is given. Find the effective capacitance across XY. I would like to say that just open XY. Just open XY. You will find. Clear? Listen to me. This is C, this is C, this is C, and this is also C. So C1 by C2, C by C is 1, C3 by C4, C by C is again 1. So I would like to say that C1 by C2 is equal to C3 by C4. This condition is balanced. I would like to say that. Here, at VAB, C1 by C2 is equal to C3 by C4. So this is the balance condition. C1 by C2 is equal to C3 by C4. Then there is no charge flow through circuit. Here C1 is C and C2 is also C. C by C and C3 by C, that is C by C, is balanced. That is 1. So there is no current flows through circuit. Therefore, the effective capacitance is C. This is called Wheaton's balanced circuit. Thank you for watching. We'll meet again with a new concept. Till then, bye.